Welcome to Akamai API Security Use Cases. We've put together a comprehensive list of API security use cases, and in this module, we'll walk through each one, highlighting key insights and real-world relevance along the way. Full API inventory, understanding your API attack surface, understanding your data exposure, meeting regulatory compliance, detecting threats, blocking attackers, aligning your network and application security, faster delivery of secure APIs, and implementing API security remediation. Let's begin. The first and most important step in securing your API estate is getting a full and comprehensive overview of every API and its individual security posture. Akamai API Security can leverage multiple sources depending on your specific environment. As soon as sources send traffic, a PI-specific communication is evaluated, and a full inventory is created showing the number of hosts and APIs throughout your environment. After Akamai has identified and inventoried your APIs, you can investigate each individual API and all its parameters, including the type of data they exchange and how they are consumed. Once you have the full inventory, you have a clearer picture of your API attack surface and can make better informed decisions. Akamai provides a full overview of all security issues across all APIs in your inventory. The classification of the security issues is based on our different modules' posture, runtime, data, and recon, and assigns a severity level to each. This provides you with a quick overview of where to focus initially as you work through closing your API attack surface. Akamai allows you to investigate the data payload exchanged across APIs, which allows you to ensure data compliance. Akamai has a set of built-in data types and can define your own. Once data types have been defined, they can be leveraged in policies to trigger automated responses. The API inventory also provides an overview of the data types on a per API basis, allowing you to understand the relationship between specific functionality, for example, a login API, and the type of data traversing it. Akamai allows you to create data type tags for specific data regulations, so you can track the applicability across your entire API estate. You can easily filter on specific data types and data type tags to see which APIs are applicable for specific regulatory requirements and what their security exposure currently looks like. Akamai detects known threats, like those described in the OWASP API Top 10, but also threats previously unknown, like the recent Log4 Shell vulnerability. We do this using various approaches. Known threats and misconfigurations can be identified through our posture findings. This would cover things like misconfigurations in the environment exposing certain functionality, or badly implemented security controls like weak cipher suites, etc. Unknown threats can be identified by learning what appropriate behavior looks like, and then using that baseline to evaluate subsequent users of the same API functionality. Akamai uses machine learning to establish this baseline per API. Once Akamai API Security has identified an active attacker, you can block this malicious user through our prevention integrations with existing inline systems. The exact blocking methodology depends on the specific prevention integration. Blocking can also be automated using policies. You can select the duration of the block or make it indefinite. You can also use policies to block, but also provide input to external systems that would inform the corrective action to implement the root cause remediation, so the next malicious user cannot use the same attack vector. Comprehensive denial of service protection requires coverage across multiple OSI layers and integrations to network infrastructure, such as CDNs, to effectively balance the load and block attackers. Akamai's machine learning-based detection and flexible policies provide an important part of that strategy. Akamai helps prevent denial of service attacks using IP deny lists, traffic patterns and custom policies, workflows and integrations with inline components for preventative blocking. APIs are powered by infrastructure and back-end technology stacks. In other words, to securely deliver APIs, you need to understand your full attack surface, which includes the non-application security pieces. Akamai provides several ways to tie these disparate views together and understand how both impact each other. For each API, we will provide a network-based view of the components involved that allow internal and external consumers to interact with your APIs. Akamai will also validate if the application team understands the reality detected over the network by analyzing the API specification to verify if certain fields or properties are either unused or undocumented. Through this process, you can easily synchronize both teams and ensure that malicious users do not abuse certain misunderstandings of your APIs. Furthermore, an overview of the infrastructure and how these pieces relate to detected issues strengthens the understanding of the interconnectedness and cross-exposure. By giving you insight into the back-end technologies powering your APIs, you can leverage this information to validate known framework issues and inform applicable upgrades or migrations. To more confidently promote API into production, we can test the security posture of each API during development. The testing can be done manually through our UI, or more commonly through integration with CI/CD tools. You can associate an API in development with our platform by providing a description of its functionality through things like an open API specification, Postman collection, a set of curl commands, etc. You then provide authentication details and select the types of security validations you want Akamai to perform. Based on the specified information, Akamai will validate the reachability of the APIs and start testing for security vulnerabilities. Once an issue has been detected, we can inform third-party solutions to trigger appropriate follow-up action. The combination of workflow integrations and automated policies can automatically feed these systems, or you can also manually trigger this step via the platform UI. The workflow can also trigger multiple actions simultaneously, for example, blocking an active attacker and creating a Jira issue with the appropriate context. The goal of these types of integrations is to leverage your existing investments in solutions, teams, and processes to follow in the case of any API security incident. Thank you for investing your time to learn about Akamai API security use cases. We have covered multiple use cases, from API inventory to threat detection and secure delivery. These use cases are key to protecting today's API-driven applications. Your commitment to understanding them strengthens our ability to deliver real value to customers together.